Hey guys, today I'm going to be going over some Boolean chips in vanilla. Now, this is cv1, and the vanilla will probably update to get to 2021 Rec Room, and there'll be a cv2, and it'll be more advanced than this and more, just honestly, I recommend it more. So this could be an outdated video, but if cv2 is not in this video, or in, in vanilla, this is for you. Let's go. Now the first thing you want to do is you want to pull out your maker pen. Now you can either do this by going to backpack and clicking maker pen, and you can click use and your maker pen will pop in front of you, or you can favorite your maker pen and grab it from behind. Now first thing you want to do is you want to open your palette, go to gadgets, and the two chips we're going to be using today is this first and third one, the Boolean chip and the comparator chip. Both of these are very customizable, and they are really useful for cv1. So let's grab two of these real quick. So you can click this configure tool right here on your palette, configure this, and there'll be different modes. Each of these is a different purpose, and they're all very useful in their own unique ways. Let's go to the equals chip right here. We have equals, does not equal, greater than or equal to, less than or equal to. Now, I'm not sure if we're going to go through the less than or equal to or greater than or equal to. I probably will. I'm not sure. We have a lot of chips to cover. Let's go. One thing I should probably mention is what Booleans even are. Booleans are either true or false. And in cv1, they're represented by 0 or 1. 0 being false, 1 being true. If you pull out your maker pen and go to wire, let's use the AND chip for example. If we go to this little red pin, which is the output, see it goes in and then goes through to out. This is the inputs. This is your outputs. It says out, and then it says 0. That means 0 is false, so it's outputting false. Now, what we're going to do is we're going to mess around with these chips. I'm going to show you what they do. I can show you basically how they can input true, how they can output false, what they can be used for. We're going to go through all of that. The first chip we're going to look at is the AND chip. Now, essentially what it does is it checks to see if both of these inputs are true. Currently, I have this one hooked up to the current toggle value. Now, since it's toggled on, see, if I toggle it off, it's false, 0. But if I toggle it on, it's true, it's 1, which is inputting 1, true. Now, this one is hooked up to the button. See, one button is pressed. Since I didn't press it, it's not putting 1. Once I put it or press it, it's going to flash to 1 immediately, like a second, and then it goes away. You'll have to look really close to see it. There we go, see? It's outputting true just for a second because the button kind of messes it up. So let's do, this will be a little bit easier. We get 2 toggle buttons. When our current toggle value. Good lord. Good fucking lord. Alright. Boom. So this one is inputting 1. This one's inputting 0. Let's press this. They're both 1. Now this output is currently 1 because both needs are met. So this is on and this is on. Or this is true and this is true. So this is going to end up being true. If that kind of makes sense. That's kind of how it all really works. Let's go over a different chip. This one's pretty simple. It's just to see if both needs are met. If they're both true, then it'll output true. This green pin will be false. If this is false though, this green pin is going to be true. The next one we're going to look at is the OR chip. Now this one is somewhat similar to the AND chip. However, instead of needing both of these, like it needs this and this to be true, it only needs one input to be true. So either this input or this input has to be true, and then it'll output true. So essentially what we're going to do, we're going to grab these 2 toggle buttons. Let's turn these off though. Good god, it doesn't even highlight something. That's kind of bro. There we go. Okay. so used to it there being a little yellow highlight around it. Okay. what we're gonna do is we're gonna wire this and then wire this. So now, if we want the output for the red pin to be true, all we have to do is press one of the buttons, this button or this button. So let's just press this button. This one is inputting true. This means this is true because only one of these needs to be on. Only one of these inputs needs to be true. So we can just turn this one on. Still, it's going to be true. This one's still going to be true. It just needs to be one of these two. So it just checks to see if one input is true or another input is true, if that makes sense. That's why it's called the OR chip. Now this is where things get a little different. This NOT chip. It's pretty simple when you think about it. The input that is put into it gets converted to the opposite Boolean value. So let's say this. If we input a true, it's going to change it and output to a false. It's changing the Boolean value. So I'm going to show you exactly kind of what that looks like. Okay, now we have another toggle button because we're probably just going to use this for the rest of them. It's the simplest way to show it. We have it back to the green pin wired to this pin. Now basically what it's doing, as you can see, when we turn this button on, it's true, it's on, so you know it's outputting a 1, and it brings this 1 through the NOT chip and converts it to a 0. So true turns to a false, 1 turns into a 0. It just changes what the input is and changes it to the opposite Boolean value, if that makes sense. It just converts it, if that makes sense. Now that we're done with the Boolean chips, we're going to go to the comparator chips. Now, these are only 4 of the 6, I believe. Do I have them? Yes, these are 4 of the 6. We'll do the other 2 at the end. I'll start with the most basic of the ones. We have the equals chip. This one is pretty simple. If the first pin equals the second pin, I don't know why it's 1, I guess I changed that earlier, then it's going to output true. 0 does not equal 1, so it's outputting a false, a 0. Oops. So let's say this. We change this 0 to a 1. 1 does equal 0, or no, it does not. 1 equals 1. So it's going to output true. This right here, if it's false, because it's the else. Let's change this. If we change this 1 to a 0, this else is going to be true because this is not true, so this is going to be true. If this is true, which is not, then this will be true. That's a horrible way of explaining it, but hopefully you understand. These two have to equal to bring a true input or output for the red pin. Similarly, this chip right here is called the does not equals chip. It's kind of the opposite, really. If this does not equal this, then it will output a true value for the red pin. So 0 does equal 0, so it's going to output false. But let's put this 1. 0 does not equal 1. So since it does not equal 1, it's going to output a true value for the red pin. As you see, it's 1. And then the else is going to be 0. They're kind of opposite in a way. Hopefully you can understand that. I can go back if you have any questions. Lastly, or maybe almost lastly, we have the greater than and the less than chip. Now, if you kind of understand where we're going with those ones, you might understand what this one is. Basically, if the first input is greater than the other input, it will output true. Same thing with the less than, same exact thing. Now, right here, we have a 0 and a 0. What we're going to do is we're going to configure this, and we're going to make this 1. Actually, hold on, let me show you first. That's a 0, it's a false, because 0 does not is not greater than 0. But if we do a 1, 1 is greater than 0, so it's going to output true. Lastly, we have the greater than or equal chip, or the less than or equal chip. I don't know if I really have to explain this one. You probably understand it, but just, I might as well in case anyone needs help with it. It just sees if 1 is less than or greater than 0. And since it is, greater than 0, it's going to output 1. And if we put 1 here, 1 is equal to 1, so it's still going to output a true. It's the same thing for the less than chip. I mean, it just checks to see if this number is less than or equal to this number, and if it is true, it's going to output true for this red pin, and a 0 for the other pin. Hopefully that makes sense. So we have all the chips here. Just give you a final rundown. We have our comparator chips and our Boolean chips, and checks to see if this number and this number is true. If they're both true, then it's going to output true. The OR checks to see if this number is true, or this input is true, or this input is true. And if either one is true, then the output is going to be true. The NOT chip converts the input to a different output of Boolean. So basically, true will become false, false will become true, different, Boolean value. Equal to chip checks to see if this number is equal to this number. If it is, then it's going to output true. If not, it's going to output false. The does not equals chip checks to see if this number and this number does not equal each other. This one checks to see if this is greater than or equal to this number. These two are 1 is greater than or equal to 1. And then this one checks to see if this input is less than or equal to this input. Sorry for rushing, but hopefully you can understand it. It's pretty simple once you get the hang of it. These chips are very useful for just making games, doing whatever you want, and they're very reliable. Hopefully you have an understanding about Boolean chips now. This was a nervous video for me. It's my first video, so ignore me rushing through everything or, mistaking my words. I'll do some more tutorials. Probably the next one will be math chips, the random chips, the variable chips. I think I did have the variable chip when I was recording, and it might just be there. You might find it throughout the video. It means nothing. Don't worry about that chip. I'll talk about that. I'll talk about that next time. Anyways, subscribe and have a great day.